Okay. Stream is up. I can see chat. Hello, everybody. I am very sleepy. Bear with me today. So, today is a sort of unofficial session 2.5 because last week, during session 2, I went over a lot of blueprinting and I was not able to cover everything because there's a lot of stuff that comes with blueprinting. So I'm going to try my best to remember all the things I didn't cover and talk about those when it comes specifically. Ooh, I gotta clean my keyboard. It is nasty. When it comes specifically to creature modding, I will try to go over all the blueprinting related things that I did not cover in the last session. As usual, if anyone has any questions in regards to anything that I'm talking about, please don't hesitate to comment and interrupt me. I would like you to stop me from continuing whatever I'm talking about because it'll be fresh in my head. So it's better than waiting until like the very end of the stream, I think anyway. How am I today? I'm okay. I'm very tired. I don't know why I've been so sleepy lately. I got like 9 hours of sleep last night and I'm still very tired. So, I don't know. But we're going to talk about blueprinting stuff today. It's going to be so incredibly exciting. I will try not to bore people. Let's see. So let's just jump right into it. So last session we talked pretty much about the character blueprint, I think, specifically just all the settings in the character blueprint. So today what we'll do is I'm going to talk about a bunch of other different blueprints that are involved with the character blueprint. I believe I talked about dino settings already. Let me actually just go in ARK's blueprint folder and see what sort of things there are. Okay, so we have an AI controller. I think I kind of briefly touched on that in the last session. This is pretty much the thing that it's actually what gives the creature an AI, what gives the creature like thought. So if you place like a character BP out in the world and it doesn't have an AI controller, it's kind of just stand there like a robot. Like it'll be like a controllable mech. Think of it that way. It doesn't have any control on its own. You'd have to pilot it. Where what the AI controller does is when it's not being piloted, it will work on its own regard. What is this? I don't even know what code this is I have set up. Oh, I see. Okay, so yeah, if we look over on the right side, it has a bunch of different settings, like how long it would flee, like the duration for fleeing. Its aggro range, that's an important one that's dictated by the AI controller. Things like that. So it's something that every creature, in theory, every creature has to have. If for some reason you are making, like, let's say a raft, like, weirdly enough, a raft in ARK is technically a creature. It just doesn't have an AI or anything, but the system it's using in game is that of a creature's. So if you were doing that, or maybe like, I believe the mechs in Extinction also don't have an AI, things like that, then you don't need one. Whoops, I did not mean to open Edge. Let's see. Dino character status component. Oh, excuse me. I talked about this last week too. This is what controls all the stats. Every single stat for your creature. Its base stats, how much stats it gains per level up, what stats it uses, things like that. All of that is dictated in the Dino character status component. Every creature needs to have one of these. Where you plug it in to a creature, let me open ARK so I can show this. So on the left side here, I have these components on the left side window here. This is where you would add that. So Acros is right here at the very bottom. Dino character status component. All you would do is go to add. You can just search your component and you would pop it in there. And that's how all the stats and stuff are controlled. Very important to have. Let's see, what else do we have? Color set I talked about last session as well. Dino drop inventory component I talked about last session. Dino entry. I believe at the end of the last stream somebody asked me to talk about this. This is... Oh man, today's gonna be tough. Sorry. Bear with me, guys. Dino entry blueprint is what the mod asset, the thing that the game loads. This is kind of a loose way that it references the character. So if you look at, if you go up to a creature and you see it's got the little HUD, the little HUD thing that has like the flashing icon and the name and all that jazz. That's what this controls here. And it also is a way to reference the character through the mod asset. The biggest thing here is the actual entry. That's kind of what it's loading into the HUD for you. I gotta wake up. Dino settings I talked about. That's what controls their food preferences. Tamed inventory component I talked about. Damage types. Okay. So, generally, you won't have to make your own damage types. I'll say that much, especially if you're starting out. When we come into our character, if I go to our blueprint on the left, which if you don't see this, or left, if you don't see this on the right side, all you would do is come up here and you'll see there's a class defaults button. All you do is click that and it'll pop up over here. So we're going to search attack. And if we scroll down a bit, we will come to AI and we will see our attack infos. This is where we set up our actual attacks. So our bites, our stomps, our tail smacks, whatever we want to do as an attack. And if we keep scrolling down through this, we'll come to melee damage type. And right here for Acro's bite, I have damage type, melee, dino, carnivore, large. This is a default damage type that most large carnivores use, if you couldn't tell by the name. Things like Rex use this. I think Aloe is a custom one, so not Aloe. Not sure if Spino uses it for the bite, but it probably does. And all you do is you would just plug that in there. If you were to actually open the damage type blueprints, which let me open Acros for his shield bash move that he has. It's not a very large. I need to stop yawning. This is rough. It's not a very large blueprint. Most of the time, like I said, you don't really need to make a custom one. Most of the settings will... you should have a blueprint somewhere in the game that has the settings you want, so there's not really usually a reason to make a custom one. Unless specifically there was like a damage type you were wanting to fall under. So if anyone recalls in the first session, I talked about dino settings and how you can choose damage adjusters, right? So let's say I wanted to make a specific damage type because I wanted herbivores to take less damage from it, right? So as long as it's a child of that class, then you can tweak the settings that way as you see fit. That would probably be one of the only reasons you were wanting to make a custom one, unless you wanted one that had like, it gave a specific buff or debuff on hit, things like that. If we look here on Acros, let's see some of the settings I enabled. Apply momentum to big ponds. So that means large creatures like Bronto and Rex, they'll take impulse damage, they'll get knocked back. Impulse resets dino velocity, so there's another one. If we scroll, we have target class damage scalers. So this is actually set up so if this attack, or this damage type rather, hits a primal structure, it's going to do 20% extra damage. So this is a stronger attack for structures, specifically. And that's kind of damage types. There's not really anything too crazy with them. And we have a few different ones there. Engram entry. So this is a very tiny blueprint, but it's a very important one. An engram entry is, if you can guess by the name, it's literally an engram for ARK. In our case, it's a custom one that we have set up for this specifically. It's Acro's Saddle. They're very simple blueprints, but they're very important. They are loaded by the mod data asset specifically, which I will talk more about the mod data asset in session 3, because that will come with actually cooking the mod, getting ready for it to cook, all that jazz. So, let's see. The first things we have in the engram entry are the required character level and the required engram points. So, when you look at your engram list and you see what stuff you can unlock based on your character level and how many points it costs, that's dictated by this setting here. So in Acro's case, you cannot unlock the saddle until level 76, as I have right here, and it costs 43 points to unlock it. So you would need 43 engram entry points or level up points to unlock that saddle. We have give blueprint to player inventory. That just means that you I believe it means it actually shows up in the engram list. I could be wrong, but I'm 90% sure that setting dictates whether it's like you have to find the engram, or if it's actually one that you just like learn from your engram list. Can be manually unlocked. Yeah, that just means that you can choose to spend points for it. Tech engram should be self-explanatory. And then we have the blueprint entry, and this is where we plug in the actual item that is locked behind the engram. So in this case, we have the actual Acro's Saddle, which we won't see the craft option for this in the smithy or in our inventory if this isn't here. It's based on the item itself. Extra engram description. I've never messed with that. I don't think it's important. Engram requirement sets. That just means like, if you're trying to learn stone in the game and it says you need to learn wood and so on, that's pretty much what that is. So you can't, you could tell it, you can only learn the saddle if you've learned XYZ, right? Engram group, we have a few different ones. This is just kind of the expansion or whatever that it's tied to. It's for filtering purposes in the engram screen. ARK Prime is just like OG vanilla ARK, so you can usually leave that default. Engram category, we have a bunch of different ones here. I could probably change this to mod specific now, or I could put it under saddles. But yeah, that's an engram entry. So they're very simple, and they're loaded by the mod data asset. Next, let's see. We have the primal items. So there's a bunch of those here. So we have primal item consumable egg. We have egg fertilized. And then, yeah, that seems to be most of them. Not seeing the saddle, must be in another place. Primal item resource apex drop. So eggs are also pretty self-explanatory. I'll open acros. So what's important to note with a creature is there is two types of egg blueprints you want typically. There's the unfertilized, which is just primal item consumable egg, whatever. And then there's the fertilized one, which is always a child of the original one. So in this case, I have Acro's egg, which you'll notice in the top right here. It is a child of egg extra large. So that's the like class or tier of egg, which is important for kibble. Typically, you would always want to make your egg a child of one of these classes. Otherwise, you won't be able to use it for kibble crafting. And if I scroll through here, we're going to see I haven't really edited any of these settings because the eggs kind of, have all their settings already in place. So if we come down to descriptive namebase, we see Acrocanthosaurus egg. If we come to the mesh material override, that's just the color of the egg. We have the size of the egg. We have the weight of the egg. Those are really the only settings you're going to want to be worrying about. We have the HUD material for the egg. And what is this one? This is the egg dino alert. So if there was an egg in the wild and you picked it up, you can list the dino tags here for what it's going to upset. So it's very simple. Like, again, this isn't a blueprint you need to really be editing. Like, if you look on the right side here when I scroll, like there's only like 5 of those little edited arrows. So it's not a blueprint you need to worry too much about. And then if we come into fertilized, so we'll see here, again, like I just said, this is a child of that previous egg blueprint. So we're going to see a few different settings here. So we have use item durability, which is the egg's health, basically. Show item rating as %. We're going to keep scrolling. Let's see, what's this? We have fertilized acro egg is the name now. The lifespan override is set to 0 for some reason. I guess that's just a default egg thing. I'm going to assume that's what that means. Item stat infos. This is where we can do like the health and stuff. Come down. Dropped item generic fertilized egg. So it has the nice little egg glow. Max item quantity. We don't want the fertilized eggs to stack, so we have them set to 1 only. The egg minimum and maximum temperature. So these are the thresholds for the temperature that the egg is satisfied, where you can actually incubate them. We have lose durability per second. So again, most settings don't really need to be changed. And in my experience with blueprints, what I find helps the most. So let's say, for example, I have this egg and then a fertilized egg, right? If I want to know what settings are like generally edited, I could just open like Rex fertilized egg, right? I can look at Rex's fertilized egg and see what stuff has changed, which if I do that, I'm pretty confident I'll see like, a variation on the minimum and maximum temperature. Like, you want to look for these arrows. Those are usually your guiding light when it comes to like seeing what stuff needs to be edited and what stuff doesn't. Here, this is important. Egg dino class to spawn. This dictates the actual character blueprint. The fertilized egg is going to spawn. But like I said, you can open a similar blueprint, take a look through it, keep an eye on the right side to see if there's any like little undo arrows, because that means the variable's been edited. And just kind of take notes. Like, be mindful of what stuff you need to change and what stuff you don't. It is a lot of info for me to walk through and cover, but fortunately, especially if you're starting out, I can confidently tell you, you don't need to worry about 70% of this stuff. If you're making like a variation of an existing dino, you don't need to do a lot of this custom info. It becomes more advanced the more involved in this you get. And if you are wanting to edit certain things, just do a side-by-side comparison of other creatures in the game. You know, there are other blueprints, things like that. It's a good way of knowing what you need to have and what you don't need to have. Like, if you look at most of these other creatures in the game, you'll see they have a dino entry. You'll see they have dino settings. They'll have an egg. They'll have an engram entry for their saddle, a character status component, things like that, right? Like, you can figure out all this info just by, like, tracing a little, like, detective line through this stuff and kind of, you know, seeing how this works. That was a bit of a tangent. So we have the eggs, which we don't need to worry about. I don't see the saddle in here. I think that might be in here. There it is. So one of the last blueprints for a creature would be the primal item armor, which is generally their saddle. So if I open that up, you can bring this down. And you'll see Akros is actually a child of the Rex saddle. So exactly my point there, right? Like, I don't really need to make a fully custom one. I can just take one that's already got its important info set up and just make a child of it. So if we scroll down through here, we're going to see not really a lot of edits. The edits that are here is the equip requires owner tag. So what this is saying is you can only equip the saddle if the creature tag is acro in this case. Scrolling down, excuse me, we have actor class attachment infos. This is where you would plug in the actual mesh for the character, and it dictates like how the mesh actually moves with animations and things like that, which I believe you have. Yeah, animation mode, use animation blueprint. So this just uses the parent animation blueprint in this case. Keep scrolling. There's the name, acro saddle, the item description, equip an acro with this to ride it. It's all very self-explanatory. Keep scrolling. Let's see, we have crafting requires inventory components. We have default folder path, so I have saddles, ARK Edition saddles. That's just the folder. You can find it if you're filtering it in game. Yeah, so I don't know. It's hard to talk about blueprinting because it's all kind of, it's settings you really have to experiment with. Like, I can give you like info on what some of the settings do, like I've done already, but most of the time you don't really need to worry about a lot of the settings. Like, I think I've talked about the important ones, so that's really what you would need to be concerned with in regards to character blueprinting. And we're already 30 minutes into the stream. So what I'm going to do for the rest of the stream is I'm going to talk about the big, crazy, important graphing part of blueprinting. Now this part, again, I'd say this is more advanced. This isn't really beginner entry level stuff you'd want to be doing with a character. It can be, depending on how complex you want the character. But graphing is this business here. So when I come to my acro character BP, it's this nice big thing we have in the center here. And if I just scroll through this real fast, it's going to look super intimidating because there's just a lot of boxes here, a lot of little wires and cables. It looks almost like a weird little motherboard microchip thing, which it kind of is. A lot of this stuff goes hand in hand with each other. It will take some time to learn this. Fortunately, this is also a very common system with Unreal Engine by itself outside of the dev kit, so you can also research a lot of this just by looking at Unreal Engine graphing tutorials. Do you only use blueprinting for your acro? No, see. Yeah, so I think one of the last dev kit updates allowed us to do C++ editing. But no, You don't do that for this whole time that I've modded, this whole 8 years. I have never touched C#, C++, any of that type of code language. You don't need that for character blueprinting. You only really need graphing if you're going to do stuff like that. So, okay. I'm trying to like mentally prepare for walking through this because graphing can be involved. So what I'm going to do for the rest of the stream is I'm going to actually just kind of go through acro. I'm going to go through my blueprint for acro, and I'm going to talk about what some of the graphs do and how it could be utilized for your own creature. If anyone has any questions, please comment, interrupt me, ask me what this means, how this works, so on and so forth. Because it can be really easy for me to glaze over something here. So with that being said, please bear with me, everyone, because graphing can be very daunting and also kind of boring. I think if you're just watching me go through it, it can be boring, but I'll try to make it interesting. When you kind of start to get how it works, it's actually pretty cool, I think, personally. So how the general process, how graphs execute, how they proceed, whatever you want to call it in game, is you have a function. We'll come to, let me see if I can find like a simple one here. One that would just be easy to understand. Okay, we'll do this one. So I'm going to zoom in as much as I can here. So generally, how graphing works, we have a function or an event. That would be this red box right here. And we see it's called start adrenaline rush. So for acro, this is the function that triggers its adrenaline. It gives it the buff. It makes it have that invincibility period during the roar. This is what triggers all of those events. And how a graph works is it starts at the beginning of this function, and all these little white lines are execute nodes, and they just carry through doing each node, each function, until they stop or until they come to a branch, which we'll talk about. So, start adrenaline rush. So this triggers when Acro does his adrenaline animation. There's a notify in the animation that tells this to be called. And we come to a node here, which is a sequence. So what a sequence does is we have then 0, then 1. It is first going to do everything it can on then 0, on this first line. When all of this is done and executes, it will carry on with the next one. And so on and so forth. I can add more pins, so I can have it do a whole bunch of things in a specific order. I'm going to remove these because I don't need them. So the first action is has adrenaline. This is a set node. So variables, which we'll see on the left side here, it's all these fun little colored things. The first and the most common type of variable we have is called a Boolean. If we come to class defaults and we see all these checkboxes, checkboxes are Booleans. That's the type of variable they are. They are either true or they are false, which is dictated by the check mark. So the first one we have is I have a set Boolean for has adrenaline, and that is checked. So what that is doing is as soon as this executes and gets here, it is telling this blueprint Acro has adrenaline. It is checking the box. The next thing it's doing is I have another set node, and this one is a float. Now this is another type of variable. A float is specifically a number variable. So it is going to have some kind of number information stored. The health of a character is a float generally. The amount of damage is a float variable. The delay between an attack or an attack interval is a float. Those are some examples of a float variable. After it tells Acro it has adrenaline, it's telling it its adrenaline current value is 0. Acro's adrenaline can only activate when it exceeds a certain amount. So once it activates, it is resetting that amount. So there isn't any sort of weird bugginess with activating adrenaline. Here we have a few functions. These are clear timers. What these are doing is there are some timers in place with Acro to start decreasing the adrenaline if it doesn't take damage in a certain amount of time. And also, if it doesn't take damage in a certain amount of time, to stop tanking. So it comes out of its shield stance and goes back to a default stance. Once these two execute, it is telling it to stop those timers. Don't worry about it anymore, basically. And then after that, we have a function which is give adrenaline buff. That should be self-explanatory. If I double click on this function, it will come into this graph here, which is very simple. We have a static add buff node. That is a type of function for adding buffs to a character. We have for character is plugged into self. That's referring to this specific Acro entity. And it gives them the buff. Then I have a function which tells its stance to not be tanking. It needs to come out of the tanking state when it has adrenaline. And then I have a HUD notification for the player. This is for a new specific thing for TLC Acro, so I won't really talk about it right now. But generally, that is the process of a graphing, is you have a function or event that gets called in some circumstance, and then it just activates a string of events, or it disables a string of events. This is the general workflow for graphing. On the left here, I'll talk a little bit about some of the different variables that you have. So I'm going to click this. So these are pretty much all the different variables you can have. You can also set up variables that reference very specific types of blueprints. So you can create a variable that references a dino character. You can have one that references a player character, things like that. Excuse me. So the first one we have is a Boolean, which I talked about already. Those are the true or false statements. Those are probably going to be the most common ones you run into when it comes to graphing. Next we have a byte. I've never used a byte variable. I believe they can come into play with certain character reference tags, like the ID of a character in a game or something. And then we have an int, an integer, and an integer 64. I've never used an integer 64. I think I've only used regular integers. An integer is basically a number without a decimal. That is the uniqueness between them and a float. Is a float is able to be a decimal number, whereas an integer can only be a whole number. So if, for example, in a graph, I wanted to track the number of hits a creature has taken, I would use an integer, because you can't be hit 4.6 times, right? You are either hit 4 times or you're hit 5 times. So that is where you would use an integer. Whereas a float would be if you wanted a very specific number, maybe the percent of health a character has left, or their exact health value with the decimal included. Maybe their melee damage multiplier. Those would be floats, right? They are decimal values. They are percent values. They're more specific numeric values. Next, we have name, and we have string, and we have text. I'm going to be completely honest. I don't think I know the proper difference between the three of these. Generally, what I use is a string, because they can be converted to a name variable if they need to be, or a text variable if they need to be. But the commonality all of these have is these are text as they are read in the game. So a name variable, what I would assume generally is if you are referencing the name of a joint, or the joint in like a skeleton, or the name of a specific creature tag. If maybe it was going to do more damage to a specific creature type, you could reference it by name tag with a name variable. Whereas strings and text are generally more involved text, so you can have actual characters in those. The name variable generally doesn't. I believe that is what the difference actually is. A name, I can't have like parentheses or semicolons, plus signs, minus signs, things like that. Whereas a string is where I can actually use that info and it will be displayed in game. Let's see. The last few we have vector, rotator, and transform. A vector is generally used for the location or speed of a like impulse or force. So let's say I wanted Acro to be launched to the like northeast and up, right? So the vector is going to have the XYZ coordinates. It's going to be 3 different values that you input based on the x-axis, the y-axis, and the z-axis. And that is generally what you're using a vector for. Meanwhile, a rotator, I believe a rotator also usually has 3 values, but it's specifically for rotating on those axes. So it's if you want to rotate on the x-axis, rotate on the y-axis. I think that's the z-axis, sorry. The y-axis would be that one. Or rotate on the z-axis. You get the idea. So both of those are going to be using the XYZ axes, but one is for actual movement, translation, and the other is for rotation. Then we have the transform, which it looks like that's just all 3. So you can have the translation, the rotation, and the scale or size of the object in this case. I don't think I've ever used a transform variable, so that's not really one you need to worry about. But if we go through my little variable list I have on the left here, I have like is tanking. That's a Boolean. It's either he is tanking or he's not. We have tanking damage multiplier. That's a float. That's the damage reduction Acro gets when he's in the tanking state. We have adrenaline base requirement and current value. Those are both floats. We have has adrenaline and is roaring. Those are Booleans. We have required taming food index, which I don't even know if that's being used anymore. I wouldn't worry about that. Here we have a unique one. So we have a variable that's an animation montage. So this is specifically for referencing a specific animation if I want, which the cool thing about all of these is if we come to the top of our blueprint here, we can actually see all of these variables. So like those is tanking damage multiplier I just talked about, those are right here. in the character blueprint. So we have his tanking. It's a checkbox. Tanking damage multiplier. It's that float value here. Those animation montages, they're plugged in right here. Yeah. So I guess that's kind of what I can cover as far as variables. Does anybody have any questions as far as variables, how that stuff works? Any at all? Okay. So I guess the next thing I can come to would be actual functions and events. So, I need to catch my breath. Okay. So the next part of graphing that I'm going to talk about is functions and events. So variables are the settings that will dictate specific actions in the character, right? Like, has adrenaline, that's telling it aggro doesn't have adrenaline, or he does. However, variables and things like these need to be called on. They need to be executed. And this happens through events and functions. Now, the reason I'm saying events and functions is they are two different things. So on the left side of my screen here, I have what are considered functions. And then a few of these red objects in here are events. Seeing if I can find some that are specific, like different things for reference. Having a hard time finding one. So, for example, start adrenaline rush. This is a custom event. This is one that I can make by just right-clicking in here and typing custom event. And we'll see add custom event here. And then I can name it acro let's build. And that's an event right there. And the thing with events is generally, unless it's one that already exists in game, the events also need to be called by something. And this can be a lot of different things. For example, when I mentioned the start adrenaline rush, so here we have an event blueprint animation, notify custom event. It's a big name, but what this does is this triggers when an animation has a notification in it based on name. So if I go to acro, I'm going to just open his adrenaline animation. Let's see, where is it? Here we go. So here we have acro's adrenaline roar animation, right? Now we see here, we have these little notifies, right? So we have melee swing, which is the actual like hit for attacks. We have the actual roar here. We have camera shake. We have a footstep. We have the actual particle when he's got his little spit going everywhere and everything. And then we have this one right here, which is a custom notification. In this case, all it says is adrenaline. And what happens is okay, so what happens is once it hits here, right, when the animation gets to that point and crosses over this, that is going to trigger this event. It does not matter what the name is. Whenever any type of notification of this type happens in an animation, it is going to trigger this event. And what this box is doing is, you see we have switch on name. So right here, I have a name variable coming out of this event. And what it's doing is when it feeds into this, it is looking for that name that it crossed. So in our case, we had that notification called adrenaline, which is right here. So what it's going to do is it's going to come up to this event, which is start adrenaline rush. And you'll see these are actually the same event, but one is blue and one is red. And the reason for that is generally blue functions like this are being called, they're being activated. And that is how this event gets triggered, because this one is calling that one based on the adrenaline. And that's generally how events progress. The other type of node you would have in this case would be a function, which generally these are much larger graphs. They're kind of their own independent graph that will do specific functionalities. So in this case, I'm going to open like a default one. So I'll do adjust output damage. So the way that you can tell this is a function is if we come to the top here, we see the actual name of the function. And the first node we should see should be purple like this. And this is basically the origin function. So whenever this is called, it starts here. And depending on if it has this, which is called a return node, it will end here. Generally, with functions, is they're kind of narrowed down specific circumstances for things. So let's say in Acro's case, as an example, maybe this one works. Yeah. So here in what's called the event graph, this is kind of the main hub of graphing. I have a function for Acro that says do ally adrenaline roar. And it's a blue function because it's being called. And if I double click it, you see we start with a purple one. And what this is like I said, I could have all of this code out here, right? But then it gets messy. So instead, this is a specific set of code that's compressed into a specific function. So in this case, if I wanted other things to reference this, I can just have it call the function instead of copy pasting that huge chunk of code every time, right? So like if I wanted something else to trigger this, I can just say do ally adrenaline roar. If I wanted something else to do that, you get it. It just kind of calls the function and kind of narrows down like big expansive code like that. So I'm going to open this function, which is blueprint adjust output damage. Now, this is actually a function that is set as a Boolean. So if you come into our class defaults character, I'm going to go to attack and scroll down here. Under Acro's byte, we have right here, we have use blueprint adjust output damage. And that's a Boolean. It's a checkbox. It's either being used or it's not. And I have that checked, which means whenever Acro is doing this attack, it is going to call this function. And what this function is doing is it is changing Acro's damage, its damage type, and also the impulse, the pushback of the Acro based on settings that I'm dictating through the graph. So I think this is a good graph to show like an example of like how you can make very custom specific things. So the thing this is doing for Acro is, for those of you that are and maybe aren't familiar, Acro has an ability, a passive ability, where it does extra damage to targets that weigh less than it. the more of a disparity in weight, the more damage it will do. So if Acro is fighting a Rex, it's not going to do extra damage. But if Acro is fighting a Stego, it's going to do slightly more damage to it. And if Acro is fighting a, I don't know, what's something tiny? A Pegomastix, it is going to do a lot of extra damage because the gap in weight is huge there. And that is what this graph is doing. So the way this executes is, first it is being called. We have two variables that are coming from this function. We have the attack index, which is a reference to the attack info. So in this case, Acro's bite is index 0, right? The way I have it set up here is kind of just anything above 0. So this can apply to literally any attack if I wanted it to. We have the original damage amount, which is the damage that it would be doing to Acro, or to the target, sorry. And what I'm doing is I'm having that come into a variable immediately because I want to have that saved as some kind of reference. I don't want to edit the damage until after I have it saved in some kind of reference. So in this case, as soon as this function executes, I basically tell it that damage it was going to do, that's locked away right now. Okay, we have it kept as reference for whatever we need to do with it. And then lastly, the last variable we have is the hit actor. And this is a reference to whatever gets hit by the attack. So it's an actor. So this could be a dino character. It could also be a structure. It's not specific to an NPC. It is whatever object actor, in this case, is being hit. So once we lock down that damage amount to a variable, we are coming to a sequence, which again, like I said before, it is going to execute all of the first part of a graph and then is going to execute all of the next part. It is going to do it in a sequence. The first thing it is doing is it is coming to a branch. Now, remember how I said Booleans are probably the variable you're going to see the most? Branches are probably the node you're going to see the most. These are incredibly helpful. They are incredibly simple to understand. Literally, you have them get called on. You have a condition, which is set by you, and then it goes true or it goes false. So basically what this does is, depending on the condition, it will either execute one path if it's true or a different path if it's false. So an easy way to think of it is, let's say trying to think of something that exists in ARK that would be easy to understand with a branch. Well, I know there's a billion things, but I'm really struggling to I'm blanking on one. Let's say Yudi's roar buff, right? So Yudi's roar buff, when it does that attack, it is looking for allies and enemies in the vicinity, right? If it finds allies, which is a condition you can set, it will follow the true path and it will give allies the buff. If it does not, which is false, it doesn't do anything, right? It doesn't execute. So that's an example of something you can do with a branch. So in this case, the condition I have is if the attack index that's called is less than a certain amount, which in this case, it's always going to be true. There's not really a reason for me to have it set up there in this case, but that's generally what a branch would be. And then we have the graph is calling Acro's attack info specifically for index 0. It is grabbing its damage impulse, which is the knockback amount, and it is grabbing the damage type, which are being set in 2 nodes here. And much like the original damage node, they're being set up for reference. So once we have all those references set up, we can come to the next part of our function, which we're doing a cast to a primal character, and that's being connected to the hit actor. So the first thing it's doing is checking if the hit actor is an actual character. Now this can be a player or a dino. If it's true, it's going to go to the next part of this graph, which is a function I have set up. If it's false, which is this cast failed here, it's not doing anything. It fails, and this counts as the end of this chain. Now, if it is the end of its chain, it is going to go to the next part of the sequence. It's going to go back to this, and it's going to a return node. Now, a return node is, let's say in this case with an attack, the attack called this graph, and now what this is doing is this is returning the information it got from its execute to the attack. So in this case, you remember how I mentioned we want the amount, the damage type and stuff to be locked away in some kind of reference? So this is why. Because this cast failed, we're not editing these settings, right? We want them as their default values, and we are outputting them through the return node as their default values. So if this cast failed, there's no uniqueness with Acro's byte happening here. It's going to just act as a normal Acro byte based on the settings I have in the attack info on the side here. However, we're going to come back to this. Now let's say the cast didn't fail. Acro did its byte and it hit a primal character. Now the next thing it's going to do is come to this function here, which I have, which is small target. Now if I click that, I'm going to go in here. You're going to see some really goofy math that I set up. But basically what this is doing is this is checking if the character Acro is hitting is a lower weight than itself. So we have the character coming in as a reference. We have their drag weight being referenced. The first thing we have is a sequence going into a branch. We have so the condition for this branch is drag weight. So the character's drag weight needs to be less than B. So if the character's drag weight is less than B, which is 500 in this case, it is going to return true, which you see that's going to character is small. And once that finishes, we go to the next sequence, and that's returning character is small. If the character is not less than 500 drag weight, the character is not small. It is false, and it is being called there, and that it will return here. And once we go back to this, we have where it returns, right? So this is the returning side. So now it's going to go to this branch. If the character is small, which is that condition there, it is going to adjust the damage amount based on the drag weight discrepancy. So that's this other one here. So we have final amount, which is that damage that we put at the very beginning here, and it's being multiplied by a certain amount of the drag weight difference. And then we have that plugging into the final amount. So this is the new damage that we have. So this is overriding that original damage, and that's because it's executing later in the graph. So because we have this at the beginning, it can get overwritten by info at the end. So we have our reference here in case this fails, but if it doesn't, it will edit it here, and then it will come to this sequence, and our final amount will go there. I hope that made sense. For me, this stuff is very, like, this is one of the easiest graphs I work with. So again, I'll leave the floor for questions for a sec if anybody has any questions for how this works. But this is one example of a function that can get called. And, in Acro's case, it is a more complex creature. So you see there is a lot of functions on the side here. Now, something I can do that might actually help with how some of this works. Here, I will angle that here. Let's see, overrideable functions like the current damage one are pretty useful. Are there any other ones for dinos you would consider generally good to know or useful? Very good question, Lucky. Thank you for that question. That is an excellent question. Blueprint adjust output damage is for editing the damage your creature will deal to others. Some other helpful functions are blueprint adjust damage, which does the opposite. So what this does is this function triggers whenever your creature takes damage, and you can set up what you want it to do with that. So in this case with Acro, whenever Acro takes damage, this is a bit of a messy graph, so I apologize. In the biz, we call this spaghetti pasta. But BP adjust damage is calling whenever Acro takes damage, and in this case, it's editing adrenaline info for Acro, right? So this is checking if Acro has a rider. It has a different branch for that. Does he have adrenaline? If he does, it goes through here. If he doesn't go through here, is Acro tanking? If he does, go that way. If not, and it edits some info there. So blueprint adjust damage is another important one. Let's see. Blueprint can attack is super, that might be the most important one. So blueprint can attack. If we come to our class defaults and we go to attacks again, under our attack infos, we'll see a use blueprint can rider attack and a use blueprint can attack. Now the difference between these two, use blueprint can attack is for AI. It's for wild dinos, and it's for tamed ones that don't have riders. Use blueprint can rider attack is the same event, but only for riders, or creatures that are being ridden, controlled by a player. What this graph does is you can set up very specific conditions for if an attack is able to activate or if it can't. And you could also have it do different things when it does activate. So in this case, coming into this graph, we have the attack index, which is that here. It's just the number of the attack in the array, whether it's the bite or the stomp or whatever you want. We have distance, which we don't need to worry about. Attack range offset, we don't need to worry about. And we have the other target, which we can sometimes worry about. Depends there. The first thing it's doing, you remember I mentioned with adjust damage, we want a reference for something. So we have it coming immediately into a variable that says can attack, and it is false. So what this is doing, if somehow any of these conditions fail, it is always going to default to it cannot do the attack. Whatever it is, this is basically telling it don't do the attack if it fails. The only time this changes is if these conditions execute successfully and you tell it can attack now. So after that, it is coming into a sequence, which is a very simple one. First, it's going into a switch on int. And then once all these execute, it is going to a return node that is checking whether it can or cannot attack. And the first one will go through 0. So that's the byte is that attack index. The first condition I have, it probably doesn't make a lot of sense. You see a variable that's like troll is nearby and bluff roar. This is specifically for a new mechanic for Acro that I'm working on. So that's basically checking if these events are actually happening or active. Basically, I don't want Acro to be able to bite when this stuff is going on. So if they are not happening, which in this case would be true, it goes to can attack, which this is a function that checks for all the basic settings of the can attack. So we have like prevent when swimming, activate attack range, the attack interval. If all of those things are good, like if they're safe, then it is true. It's going to go to the next one, is Acro roaring. If he's not roaring, it will carry on because we don't want Acro to be able to bite while he's doing the adrenaline roar. Does Acro have a rider? Is somebody riding the Acro and controlling it? If it's true, it's going to go to this one and it's going to execute a different function. Which that's interesting. Okay. Is tanking. If that is false in both conditions, it's going to carry on to this one. Basically, it's just a bunch of conditions and stuff to check whether it's able to attack or it can't. Going off of your question, Lucky, that is another very important function, I would say. I'm sure there are a few others I'm forgetting about, but generally, especially for starting out, I'd say the most important would be the blueprint can attack functions. And then maybe like the blueprint adjust output damage and the blueprint adjust damage. My nose is so itchy. Keep in mind, with these, an important thing to note is you may have to actually enable them in the character defaults. So if I go adjust damage, let's see. Yeah. So here we have a function use blueprint adjust damage. So by default, this is off. So even if I had a bunch of stuff in the adjust damage here, it's not going to call that event unless I have this checked in the character's defaults. Most functions work that way. It's important to note that. And this is just, before you asked that question, this was just something I was going to show quick. So I'm going to hit play. Actually, hold on. Let me do this in a different window. Why is that so tiny? Okay, so here you see me playing the game. I'm going to spawn in an Acro. I have an Acro, right? Now what I'm going to do is I'm actually going to drag this off screen and I'm going to go back to the graph. And you'll see now we have a yellow box and it says simulating. And what that means now is if I start performing actions with Acro, you're going to actually see these graphs get triggered. So if I trigger his shield stance, which you can see it happening up here, it's a different function. So it's very quick, but you can see some things happening there, right? And what's happening is every time I'm pressing C, every time I'm activating Acro's adrenaline, or not adrenaline, his shield stance, it is activating these functions. Same with things like these. Let's see, what's a quick one I could do? I could do can attack. So I'm zooming out very far so you can actually see it. But this is his can attack graph, right? So if I left click, So that's Acro's byte. And you'll see these graphs are being called. It's very quick, but this is how the function occurs. So we're going through all these. You see has rider is true, so it's going through that top one there. This specific thing, which is just checking for the byte interval, so I can't click over a certain speed, right? So you'll see actually... So see I'm spam clicking it, right? But you see it's only coming out here a few times. And the reason for that is because this can attack is returning false because I'm not meeting the attack interval requirement. I am clicking it too fast, so it is returning false until I meet the interval delay in which it goes true. And that is why that condition is happening. Another one we have is, let's say, the stomp. So if I right click, you'll see same thing there. So we have our condition. And then I can do it as soon as that gets met. Yeah. So you can see how the events carry through. It is very daunting at first, but once you kind of understand that it's just like it goes if then but, that's pretty much how most graphs work in this case as far as blueprint graphing is if this happens then this happens but this will happen, right? Like it's cause and effect. That's pretty much how all of these work. Once you get that in your head and you start kind of working through this, it will make a lot more sense. How do you make a dino lay an egg in a nest or area? That I do not know. I haven't done that for any of my creatures. That would be something you would want to look at rock drake or wyvern. You would want to look at their graphs, which I guess kind of segues me into my next point, is if you want reference for graphs, you can just open other creatures and see how they work. For example, Acro's shield stance, his switching, a lot of those mechanics node system was actually taken from Iguanodon with its biped to quadruped stance. That's how I figured out how to set that up, was looking at Iguanodon, and then, you know, making tweaks where I needed to. So you can look at other creatures for reference on how they have these things set up. Man, I have like... That's my dog, I apologize. I have like a mustache hair that's like standing up, poking me in the nose. I think I just got it. What is the network time in seconds node doing? Thank you for asking. So I found this out recently. Network time in seconds is very important for when you're doing server side stuff. Basically what that's doing is when the very end here, this is triggered, we have a network time in seconds. One of my dogs really wants to see me right now. At the very end of the Acro's byte, we have a float set here, which is last time byte attack. And that's being set by the network time in seconds. And what that's doing is that's basically taking the game time, not like the afternoon, nighttime, evening thing, but like specifically like how long the server has been running or whatever. And that's plugging it into this. And I am using that as a more unique closed system for attack intervals. So when we come back to the beginning here, if we look at this function specifically, we have the network time in seconds, and we have, well, no, that's the wrong one. We want that here. There we go. So we have the last time byte attack, which was that one over there, and we have the network time and seconds. And we are subtracting the last time byte attack from the network time and seconds. And what we're doing with that is we're bringing that into this returns true if A is greater than or equal to B, which in this case, A is that subtraction. And then we have an adrenaline byte speed reference, which right now I have that as 2. So what that's doing is Acro can only do this attack if the attack interval is longer than 2. Basically, if you have waited at least 2 seconds, this will return true. You'll be able to execute the attack. And that's what this network time in seconds is doing, is it's basically set up in a way that I can check for specific attack intervals. In this case, specifically, what I have it doing is when Acro's in adrenaline, I have it set up so as you perform the attack, you'll slowly build up like a speed, and you can actually attack faster if you keep going. So it's kind of like bite, 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 bite. It becomes like a sort of combo move thing. And what it's doing is every time it executes here, it's slowly reducing that byte speed reference. So it starts at 2, but it can go down to, let's see, do I have it as a clamp? Yeah, so it stops when it hits 0, basically. So it can reduce it to have no interval at all. So the example is I will play this and I will show you the graph. I will bring this up to my top screen. The first thing I'll do is show you the adrenaline when that activates, because it's calling a lot of functions. So I'm going to activate adrenaline on this acro. So I'm going to hit this button. You're going to see a bunch of these graphs start going off. Oh, unless I don't plug them in. Whoops. Okay, well, Acro's in adrenaline now. So if I come to the attack, and we watch this, and I start biting, and you can hear it too in the sound, right? You can hear the timing go down. So that's kind of all that's doing, is that's just making you able to bite faster. And you'll see now it's calling these because Acro doesn't have adrenaline anymore. It only goes up to here when it's using adrenaline. So that's kind of what that graph is doing there. I guess I can talk about replication. Okay, I'm gonna, before I segue into replication, I want to put it out there. Yeah, of course, Lucky. Thank you for the good questions. Replication is still something that I am trying to fully understand. Basically, it's how info gets relayed between a server and a client. It's still a bit daunting to me. I don't completely understand all of it, but I will try my best right now to explain the general system it's doing. So if you are playing ARK in single player, let's say, your client is the server, right? There's no back end that the game needs to communicate with. It is doing it all in one closed system. Now, if you are playing ARK through a server, there is 2 systems that you want to worry about here. there is what's called the server, and that's basically the like parent of all the information, where all the info is coming from. And then you have the client. And what the clients are in this case are the local events, the closed systems. Now, when you are playing on a server, it is important for certain events, variables, and functions to be replicated. And what this means is it is telling the server to send information to this client and vice versa. And what this does is this makes sure that info is synced and there isn't any sort of weird desync with characters or creatures. A good example of this is, let's say you are playing on a server and you are riding an acro and you just gave it adrenaline. Now, right now it's set up so, well, before I say that, so what's important to note is there are 3 systems active here. There is the server, which is the world that acro and the player are in, and then there's 2 clients. There's the acro, which is 1 client, and there's the, I almost stuck on my middle finger. There's the client, which is the, acro is 1 client, and there's the player. That's the second client. There are 2 separate closed systems. And what we want to be able to do is tell, we want acro's system to relay info to the server, so the server can relay info to the player client. Does that make sense? Now, when issues occur is when this doesn't happen. Acro may have events that aren't replicated, and acro knows they're going on, but maybe the server doesn't, or the other player. So in this case, let's say you activate adrenaline on the acro, and the acro has adrenaline. You can see it as the rider, but maybe there's another player not riding the acro, and he doesn't see adrenaline. And that's because it was not replicated to the server, and it was not cast back to this other client. Only the acro knows that this info is happening. And that's where the closed system stuff comes into play. So, I'm sorry I keep scratching my nose. It is so itchy. My mustache keeps tickling it. I gotta shave. Oh, geez. I just realized I didn't record this session. Can you download Twitch videos? I think you can. I'll have to just download the Twitch video, I guess. So, going with all that replication, we come back full circle to our Start Adrenaline Rush event. And if I click this event on the right side under its details, you'll see we have replicates. Should this event be replicated to all clients when called on the server? And I have run on server, and it is reliable. And so what that's doing is when it goes through this event, it is actually going to execute this function not locally, not in acro's client. It is going to activate it on the server. And what that means is because it is going on the server, it is going to relay this information to all clients that are nearby. So what that means is if I do adrenaline, not only will I see it on the acro because the server said so, but the other players that aren't riding the acro will see that it has adrenaline. That info will be replicated and relayed. So that's probably the best I can explain it. It's kind of hard to get into because, like I said, I'm still kind of figuring it out. But generally, how you want to look at it is for a lot of visual things or maybe like buffs and things, do other players need to know that this event is happening, right? Like, do other players need to know that Acro has this buff now? Things like that. And if they do, you generally want to replicate it and have it execute on a server as far as events are concerned. Yeah. So with that, I don't really know what else there is to touch on, to be completely honest. Let's see, there's like half an hour left, I guess. Okay, so what I'll do now, if anybody has any questions in regards to this, I'll answer any questions. If people are curious about how certain functions or things are working, I can explain them. Otherwise, I'd say this is probably about the end of session 2.5. So I think this covers all the really pivotal information as far as blueprinting. So with that, I'll leave the floor open. Does anyone have any questions about blueprinting or anything of that nature? I'm not going to answer any questions about ARK editions. I don't have an estimate for when Acro is going to release. Please, any questions be about this. I don't want to answer anything not about this stuff. This is meant to be an educational stream. So, yeah. I think what I can actually do, let me double check. Yeah. So in the dev kit, you can do a thing. Whoops. You can actually load multiple clients, and this is good for testing server-side stuff. So that's actually another player, which is me. I have it on this top screen here. I'll do this so you can see both. Or actually, I'll do that one so you can see it. So you can see I'm walking around. Like, you can tell it's replicating. I'm going to come over here, and I'm going to spawn in this guy. So this is a good way to see if this stuff is replicating. So we see acro turns, all that stuff. All the visuals are happening. If I press C, you see he's going in the shield stance on both. It is replicating. His attacks are working. If I stomp, that's working. Stuff like that. And then we can test the adrenaline to make sure that's all replicating, right? So I'll go into shield stance. I'll hurt him a few times. And I'm going to hit spacebar to activate adrenaline. Now you can tell he has adrenaline because I'm walking a lot faster, which is replicating. My muscles are all swelled up on the acro. If I do my stomp now, he's going to do his other stuff, right? So, that's a way that you can test server-side stuff in the dev kit, which can be very helpful. It is a bit demanding, so, you know, take it with a... be careful. But you see when I go under net mode here, I have 3 different options. I have standalone, listen server, and client. You never really want to do listen server. You only ever... Standalone is for single player, which is when there's no network replication. And then you can do client if you want to see server-side things. So I'm gonna hit play as client here actually, and I'll show you guys Acro's graph through a client. So if I come up here, now you'll see, whoops. So I have an Acro active, and you see we're going to have two different things now. We're going to have Acro character BP server and Acro character BP client. And like I said, this is info being relayed between the two. So client is the Acro specifically, and the Acro server is what the server knows about the client. So if I go Acro character BP server and I zoom out here, I'm gonna go into Adrenaline. So you saw those functions happened, right? And that's because it's a server, executes on server. If I go to client now, and I do the same thing again, you'll see that these ones didn't activate. And that's because these aren't client side. These are server side. So these things are happening on the server, and it is being relayed to the client. Hopefully that makes sense. Let's see. Are there any other questions in regards to blueprinting, graphing, how that stuff works? Hopefully I was thorough enough and not too boring. Seems only the root capsule component generates on-head events for terrain structures, etc. Is there really no way to get those head events for the skeletal mesh physics asset? I haven't messed with it enough to really be helpful on that question, but as far as I'm aware, I think it's pretty specifically the capsule component, right? Like I said in I think the first stream, the mesh is mostly kind of a visual component, whereas the actual capsule component is like what's being interpreted as like the character's box, right? Like where the character is being treated. I think things like IK and stuff are technically, I don't know if those count as hit events, maybe. I'm not too certain, but yeah, I think generally it's the capsule component that is specifically for hit generation events. Any other questions about blueprinting? Otherwise, I'll probably call the stream in a moment. I'm very hungry. Going once, going twice. If I wanted to do something like a custom spider shooting a web at a wall, would you know if line traces or anything of that sort would work instead of detect the wall collision? Yeah, you can do a line trace. I believe Bloodstalker does that for its like web connection-y stuff. I think it's line traces based on the camera, actually. So that is something you can do. Yeah, cool. All right, everyone. Well, I'm gonna call it here. I don't think there's too much else to say. Thank you all for tuning in. Thank you for being patient. blueprinting and stuff is pretty busy, and it can be very scary at first. But yeah, thank you all for bearing with me. I hope this was helpful to anyone that was interested in modding endeavors in the dev kit. And make sure to tune in. What is the date? The 2nd of March will be the third and final session for the stream, or the Let's Build rather. It will be talking about getting our mod ready for Cook and seeing it in game. So, yeah. Thanks everyone for tuning in, and hopefully see you next weekend. So take care, everyone.